Hey guys, happy Friday. Hopefully your test went really well yesterday. Hopefully you enjoyed that problem about the alpaca farmer. Um, and I will look at those tomorrow morning when I'm here for the ACT, and hopefully I'll have them graded for you for Monday. So today we are going to start chapter 4, and the first section is 4.1, areas and distances. So you can go ahead and start your notes with that title, but we're actually not going to get into that yet. We kind of have a precursor thing before we actually start dealing with the areas and distances. And that precursor topic is something called sigma notation. You should have seen this at some point, but if you haven't, I guess we'll catch you up today. It is also known as summation notation, because you're going to be taking some big old sums. It's called sigma notation because it uses the Greek letter sigma. It's a capital sigma. It's basically corresponds to our English or alphabetical letter S. Okay, so what it says is if we have this big old sigma, there's going to be something underneath it. It's going to give you whatever variable you're working with, and it's going to be set equal to some number. In this case, I'm just going to use general terms. On top of that sigma, there's going to be another number, and in this case, I'm using m. So, side note, m and n are integers, such that m is less than or equal to n. So you always want the top number to be bigger than your m or equal to it. And then you're going to have something over here that's going to be a formula telling you how to come up with the terms of your sum. So if I were to do this problem, what it is telling me, my first I is m. So if I plug that into my formula, I would have a sub m. And then I have to go all the way to n. So my next one would be a sub m plus 1, a sub m plus 2, plus dot, 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 all the way until I get to n minus 1 and a sub n. If you haven't seen this type of like notation, I guess, as you're counting up here, it might not make a whole lot of sense, but if you've seen it before, hopefully it should. But let's do an actual example. So this is like the general definition of what sigma notation is. A specific example if I have I equals 1, so let's use an actual number there, and an actual number on top, let's use 4. Let's make the formula an actual formula. Let's make it I squared. So what this notation is telling you to do is to take your first I being 1 and plug it into the formula. So if I take 1 and plug it into this formula, I would get 1. I'm going to add to that what I would get if I took the next number, because I'm going from 1 to 4. So if I took the next number, 2, and plugged it into the formula, 2 squared is 4. Plus, the next number I would plug in would be 3. 3 squared is 9. Plus, the next number I would plug in is 4. 4 squared is 16. I am not going to plug any more numbers in because I plugged in numbers from 1 to 4. So this is the starting number to plug in. This is the ending number to plug in. So I plugged in 1 and I got that. 2 and I got that. 3, I got this. 4, I got this. I should stop right there. I started by plugging 1 in. I stopped by plugging 4 in. So this red notation right here, what is that telling you to do? It's telling you to take the sum of those 4 things. and that would be 30. Okay, so you're using consecutive values, plugging into your formula, and then you're going to add them all up. This number down here is called the index, which is why we keep using I, but it could be anything. You can use any variable. All right, let's try another one. Let's go from I equals 3 to n of our formula is literally just I. So what is the very first thing to plug into our formula? 3 is our first thing. So I'm going to plug 3 in. And then I'm just plugging consecutive numbers in. So after 3 comes 4. If I plug 4 in as the I, well, that's just going to be 4. And then I'd plug 5 in. I'd get 5. I'd plug 6 in. I'd get 6. Where am I going to stop? Well, I have to go to n. So this is one of the ones I'm going to put plus dot 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 all the way until I get to n. And it's common to then also put like maybe an n minus 1. Whatever came before that, because we don't know what n is. N could be 12, it could be 7, it could be 4 for all we know. So we just write it this way. All right, let's do another one with specific numbers. Let's let the index be j this time. So let's go from j equals 0 to 5. Find the summation of 2 to the j power. So the first thing you're going to do is take your first number, 0, plug it into your index. 2 to the 0 power, well, anything to the 0 power is 1. To that, I'm going to add. So that was when I plugged 1 in. The next thing I'm going to plug in is 2. 2 squared is 4. Plus, the next thing I'm going to plug in is 3. 2 to the third power is 8. The next thing I'm going to plug in is 4. 2 to the fourth power is 16. The next thing I'm going to plug in is 5. 2 to the fifth power is 32. The next thing I'm going to plug in is, oh, wait a minute, it told me to stop at 5. So I'm done right here finding my sum. And when you add all those up, you'd get 63. So this notation tells you to do this work to find that answer. Okay, so hopefully you are getting the hang of it. Let's go over a couple properties. If you have the sum from I equals m to n of c times ai, and we're going to say c is a constant. So it's not a variable, it's a constant. Then we can say that this is actually equivalent to the constant times the sum of ai. Okay, so an example to highlight that, say we are going from I equals 1 to, let's just go to 3 of 2x. I'm going to put the answer down here. I would have 2 times 1, which of course would be 2, plus 2 times 2, which would be 4, plus 2 times 3, which would be 6, so I'd get 12. Versus if I did it this way, my 2 would come out. Oops. 1 right there, and 3 up here of x. So I've taken my constant out. So I drop my 2 down, and then I'm going to multiply it by the sum here. Well, this would be if I plug 1 in, it's just 1, plus plug 2 in, it's just 2, plus plug 3 in, it's just 3. So I would have 2 times 6, and look at that, it's the same answer. Okay, and then We also have the property I equals m to n summation of a sub I plus b sub I. So if you are adding two functions that depend on the I, it's the same as if you did the sum of the first one and then added it to the sum of the second one. This property also works if you are subtracting. So you can put a plus or minus. Okay, a few more here. If you have from 1 to n of 1, what do you think that would be? Well, is there anything even to plug in? No. So I would just have 1 plus 1 plus 1 plus 1 plus 1, however many times it takes me to get from 1 to n. So I'd have 1 plus 1 plus 1 plus 1 plus 1 n times. That would just be n. Think about if this was a 3, you'd add 1 plus 1 plus 1. That's 3. Be that same number. If you have the sum from I equals 1 to n of c, where c again is a constant, it would be n times c. So if this was a 2, you'd be adding 2 plus 2 plus 2 plus 2 plus 2 n times. Well, that would be n times c. I equals 1 to n again of I. That actually gives you n times n plus 1 over 2. I equals 1 to n of I squared is n times n plus 1 times 2n plus 1 all over 6. And finally, we'll do if we have I to the third, that's actually n times n plus 1 over 2 squared. These are some good number theory proofs. I'm not going to make you guys go through them. If you're interested, though, I'd love to show them to you outside of class time. Alternatively, you could always look them up. You don't need these a whole heck of a lot, but there are a couple problems we'll see eventually that they may come up in, so that is why I'm showing them to you now. Okay, the first two, definitely you want to know those. The last three, have them written down somewhere that you can reference. Okay, next I'm going to put several problems up on the screen. I would like you guys to pause the video, and then these are your homework problems. So I didn't print them out. Just go ahead and copy them down from the screen and figure them out, and then hopefully you will have plenty of time to get this done before you leave class, so you don't have to worry about anything over the weekend. And then on Monday, we will go over tests and really hit the ground running, getting more into Unit 4 and the next real big topic in calculus. All right, let me get these problems up. Okay, these are your problems. The first 10, you are just writing them in expanded form. So that means you are just writing out what all the numbers are or what all the expressions are. And then these last 4, you're actually finding the sum. All right, get those done.